Hi and welcome to Techie Create. Today we are going to see about introduction to AWS. So before stepping into introduction to AWS, let me explain about cloud computing. So cloud computing is nothing but utilizing the computing resources via internet rather than hosting it in a local, which is in a remote location. So cloud computing is a term refers to the practice of using network of remote servers which is hosted on the internet to store, manage and process data rather than a local server or a personal computer. So basically cloud computing is remote server which is hosted in a data center where we doesn't have any physical access, but we own all the access to the server via internet. So cloud computing is a computing infrastructure which is being provided by many service providers where consumers no need to bother about its configurations or setups, which means if I require some infrastructure in a cloud, then I can simply go ahead and set up using a web UI. I don't need to bother about what are the configurations I have to do and to whom I have to access. So cloud computing paves a way to building a computing infrastructure quickly in effective cost, which means by opting to cloud computing, we can eliminate the cost which we spent on the maintenance. Why do we use cloud computing? As the term defines, it is a cloud where no physical access to environment. It can be accessed via internet. So cloud computing paves a way to access it using internet but not a physical access. The major advantage of using cloud computer is we pay for what we use. We no need to pay for maintenance or any infrastructure setup. Cloud computing allows us to create or update environment whenever required. So changes to environment will reflect immediately. So unlike the server which we host in our local, we no need to bother about creating a new environment or updating an environment. It won't take any downtime. So as it is a cloud, we can scale up or scale down our environment as it requires. Top cloud computing service providers. In today's world, we have many service providers who provides cloud computing service. The top cloud computing service providers are Amazon Web Service, that is AWS, Microsoft Azure and Google Cloud, IBM Cloud and Adobe Creative Cloud. The top three companies were Amazon, Microsoft and Google. Let's jump into our today's topic, introduction to AWS. So AWS is nothing but Amazon Web Services. Amazon Web Service is the top cloud computing service provider in today's market. Amazon Web Service is a cloud computing platform which provides services such as compute power, database storage, content delivery and many other functions which will help to integrate a business. The Amazon Web Service is flexible, scalable and reliable. AWS is very cost effective that we pay for what we use. AWS has almost 350 plus services which is used widely across many organizations. AWS is a leading cloud computing service provider. Advantages of AWS. AWS is highly secure, reliable and scalable. AWS achieves high secure by giving different services to its users like IAM, security group and VPCs, which we'll be seeing in upcoming slides. Reliable. AWS provides multiple instance or multiple copies of the same data which we store so that it is highly reliable. The data which we stored in AWS won't get lost or corrupted at any cost because AWS has its own backup, which AWS will support us with the backup in case of any disaster. Scalable. AWS is highly scalable that the resources which we create can be auto scaled if it is highly 100% utilized. Highly cost effective. Pay for what we use. So AWS is highly cost effective because we pay for what we use. So resources are built hardly, that is if I am creating a resource which I was using for 1 hour, I just have to pay for that 1 hour. I no need to pay for the whole day or a whole month. AWS supports many third-party integrations, which is the main advantage of AWS. AWS doesn't restrict us to use their service alone. It also supports the many third-party integrations. huge amount of APIs for handling AWS resources programmatically. So AWS provides many handy APIs which can be used to handle the AWS resources programmatically. Like we'll be able to play around with the AWS services programmatically. AWS Crumbs. Before stepping into AWS resources, let me explain about few AWS Crumbs. Availability zone. AWS availability zone is nothing but the AWS hosted its data center or its cloud infrastructure. AWS provides an option to select its region where it hosted its cloud infrastructure. AWS is providing an option to select the availability zone in certain services where user can be able to select the region whichever the user wants. Opting to the nearest region will reduce the network latency, which means the end user experience will be quite faster. There won't be any delay due to the network latency. Security groups. Security group is similar to a firewall settings in our Windows or a Unix machine, which provides a security at the protocol and the port access level. Using security groups, we can protect our AWS resources by restricting certain IPs or certain ports. Assume like I'm having a server to which I'm going to host a web application where other SSH accesses or other port access is required. I'll just open 80 port and 443 port, and if I'm hosting the application for certain group of people, I can restrict it using a CIDR, which is nothing but limiting the access based on the IP address. VPC, Amazon Virtual Private Cloud. VPC is nothing but an isolated section in AWS cloud where AWS resources can be launched in a virtual network defined by the user. So VPC is a service provided by Amazon where we can isolate our AWS resources, where we have an flexibility to create IP address in our own range, including IPv4 and IPv6. Tags. Tags is nothing but assigning a key value pair to our resources to identify the purpose of resources. IAM. IAM is nothing but AWS Identity and Access Management. AWS Identity and Access Management is a web service for securely controlling access to AWS services. So IAM is nothing but restricting access based on the users or user roles. Assume like if I am owning an organization where I have my employees or developers accessing AWS on behalf of me, they are going to create or they are going to do some activities in AWS. I'll create a IAM rule using roles, users and group. So what I'll do is like assume like I have a developer team, testing team and I have a support team. So for developer team, I have to give all the access so that they can explore in AWS and they can use or create a resource as required. So for testing team, I no need to give all the access, which means I no need to give them a create access. They just want to see the logs or they just want to test the resource. They're not required to access the or they're not required to create AWS resource. In such cases, I'll create a role for developers and testers separately. So developer will have the access to create resource in AWS and tester will have certain access which won't be as similar to developer. So using IAM, we can also be able to give access to user level. So for certain users, I can restrict some access. For certain users, I can allow some access. So IAM is not only for restricting the access, but it is also to restrict the access between the AWS resources. So IAM provides a security credentials which can be used between AWS resources. So assume like I am bringing up a server in AWS where that particular server needs to access a database which I have hosted in a different place. So in that case, I'll provide a IAM role, IAM user to that particular server and as well as to that database server. So what I'll do is like I'll give access using access key and secret key which was generated by IAM to that particular server which has access to access the database. Useful AWS services. Below are the some of the commonly used AWS services. EC2 Elastic Compute Cloud, which is nothing but a remote server hosted in a cloud environment. EBS Elastic Block Storage. It is similar to a hardware which is connected to a computer. S3 Simple Storage Service. It is nothing but a cloud storage service. RDS Relational Database Service. RDS is a service by AWS which provides different types of relational databases services. SQS Simple Queue Service. SQS is used to communicate between a two component or a services to each other using a messaging system. ELB Elastic Load Balancer. Elastic Load Balancer is nothing but balancing the load of a server. Neptune. Neptune is a graph database service provided by AWS or the sub-service of other AWS service. VPC Virtual Private Cloud, which is nothing but a isolated network in AWS. IAM Identity and Access Management, which is used to create a credentials for an AWS resource to communicate with other AWS resources or restricting access to certain users or user groups. EC2 Elastic Compute Cloud. Elastic Compute Cloud is a virtual server hosting service provided by AWS. EC2 is created by using an AMI, which is an image provided by AWS with pre-configured softwares. AMI is nothing but Amazon Machine Image, which has a pre-configured softwares or pre-configured security patches by Amazon. So using AMI, we will be able to create an EC2 instance. EC2 instance is nothing but a computer hosted in a cloud. Amazon has many AMIs which can be used based on our requirements. Assume like if we are hosting a server or we are hosting an WordPress application in a EC2, we have an AMI which was provided by Bitnami, which has pre-configured WordPress in it. Similarly, we have other AMI providers in AWS using which we'll be able to bring up an EC2 instance with the pre-configured softwares which we required or as per our requirement. AWS provides EC2 in a variety of hardware configuration types which users can opt as per the requirement. AWS provides different types of EC2 instance which can be opted while creating an EC2 instance, which varies from RAM or CPU size and from network size as well. So the lower instance will be 0.5 GB of RAM and 1 core processor with low to moderate network. So the high configuration can go more than or beyond 100 GBs of RAM and around 100 cores of CPUs. So security group in EC2. So security group is nothing but a firewall to an AWS services. So using security group, we can configure our protocol or access to certain ports. So where inbound and outbound rule will be configured to protect our resources. EC2 can be isolated from outside world using an VPC in AWS. So VPC is nothing but a virtual private cloud where we can create our own IP addresses like IPv4 or IPv6 which won't affect any real world IPs. EBS Elastic Block Store. Elastic Block Store is a block level storage volume which is used by EC2. EBS is highly available storage which can be attached to any EC2 instance in same availability zone. So EBS is nothing but a storage volume to an EC2. So already we have seen like EC2 is an server which can be hosted in AWS using an AMI. So assume like I am bringing up an EC2 instance using a Linux AMI. So I need a Linux OS to be installed and I need to have certain softwares in that. For that I require some storage where my OS to be installed or my softwares to be installed. So for that EC2 internally creates an EBS on behalf of us while creating an EC2. Using that EBS, it will deploy the AMI which we have selected and it will bring up the instance. So EBS is nothing but an hardware which is attached to a computer. EBS is a region specific where we have to be cautious while we are creating a EBS. So EBS created in one region cannot be assigned or cannot be tagged to EC2 instance from other regions. S3 Simple Storage Service. Simple Storage Service is a cloud storage service provided by AWS. AWS provides high-speed, low-cost, web-based cloud storage. Using S3, we will be able to store any number of data which we require. So AWS will cost based on the size of the files which we store in S3. Unlike other cloud providers, we no need to pay for a huge amount of data, or we no need to pay exceeding the file size which we have already stored. So using S3, we'll be able to store up to 5 TB of file. 5 TB of file means I can store a single file with 5 TB of size. So AWS is mainly focusing on security and high reliability of storage. S3 treats all the data stored into it as an object. That is, we'll be able to store any type of files, and there is no restriction in the types of files which we are going to store. AWS provides different S3 storage classes for different purposes. Assume like I have a file which I'll be accessing very infrequently. In such cases, I can opt for S3 Glacier, where my files will be stored in S3 box, which I'll be accessing very infrequently, which will drastically reduce my cost on the storage. RDS, Relational Database Service. So, Relational Database Service by AWS provides a web-based scalable database service. RDS supports major databases such as MySQL, PostgreSQL, Oracle, Microsoft SQL, and MariaDB. RDS has an option to create a primary and secondary instance, which is nothing but a read replica. The primary instance is focused on high availability, and secondary instance which is synchronized with primary instance that can fail over to when the problem occurs. So RDS has a major databases such as MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL servers. Using RDS, we'll be able to bring up the database in the cloud using AWS RDS. Access to RDS can be restricted using IAM and VPCs. So IAM is nothing but identity and access management, and VPC is nothing but a virtual private cloud where our database will be completely isolated from internet. Using RDS, we no need to worry about managing the database or about taking backup very frequently. So management of the database is completely taken care by Amazon. It will create a snapshot based on the timeline which we have configured, and it can create a backup, or it can restore the backup on behalf of us if any data loss or if anything happens to the database. SQS, Simple Queue Service. Simple Queue Service is used to send or receive events. SQS allows application or components to communicate between each other using a messaging system. SQS is used to decouple and scale a microservices, distributed systems, and serverless applications. Amazon SQS moves data between distributed application components and help you decouple these components. SQS also facilitates FIFO to maintain the execution order of message. So the main advantage of using SQS is to communicate between two components or two distributed systems. Using SQS, one component can send a message which can be consumed by a other component. LB, Elastic Load Balancing. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instances, containers, IP addresses, and Lambda functions. ELB can handle the varying load of an application traffic in a single availability zone or across multiple availability zones. Elastic Load Balancing offers three types of load balancers that all feature the high availability, automatic scaling, and robust security to make applications fault tolerant. ELB is nothing but a load balancing service which is provided by AWS. Using ELB, we'll be able to cascade our traffic or load to a different service. I have 3 EC2 instances where I hosted a web application. I'll be adding those 3 instances to ELB. So ELB will take care of the load for those 3 instances. If my first instance is highly occupied, then the ELB will automatically route the traffic to the second instances. Or assume like I have a 3 instance, though one instance is getting down or it is not accessible, ELB will automatically route the traffic to my healthy instance. So ELB is also having a feature to auto scale. So auto scale is nothing but I have an instance where I have certain memory, like I have 4 GB of memory. My load is in peak on some hours. I cannot manually bring up a new instance during that hour alone. What I'll do is like I'll define an auto scaling rule to ELB. So ELB will take care of the auto scaling in certain limit, like if my CPU is 80% utilized, I ask ELB to bring up another instance to auto scale the traffic. What it will do is like it will auto scale an instance once my CPU utilization reaches 80. By this, I no need to worry about a huge number of traffics to my applications, which can be handled automatically by ELB by bringing up a new server to balance the load. Neptune. Neptune is a fast, reliable, fully managed graph database service. Neptune is a NoSQL database which uses graph theory, that is, it treats relationship between data as equal to its data. Neptune supports popular graph query languages Apache Tinkerpop Gremlin and W3C's SparkQL. Neptune follows graph theory, which means in Neptune the relationship between the data is treated as equal to its data. Using Neptune, we'll be able to store the data which have relationship among itself. Assume like I have a social media where I have information about peoples. Like I have a people called Johan. So Johan is friend of Emil. So Emil and Johan is friends. So that is their relationship. In Neptune, I'll store Emil and Johan as well as their relationship between them and however they are relating. They are using a social media and they are friends. They are from same city or they are from a same school. So similar details will be stored in Neptune. So this is how a Neptune works. Thank you. For more videos, subscribe to our YouTube channel. If you like this video, click on like button. If you have any questions, you can post it techie.com. In our next video, we are planning to share the same information along with the AWS console as a demo. Thank you.